Dear students, today I am going to teach you how to find the convolution sum between two discrete time signals, that is x of n and h of n. In the previous class, we learned that the convolution sum y of n is represented as summation k equal to minus infinity to plus infinity x of k into h of n minus k. So while finding the convolution sum, we need to perform different operations on x of n and h of n. First, we need to represent x of n as x of k, and we need to find h of n minus k and then multiply x of k and h of n minus k over the overlapping region between these two signals over the range k equal to minus infinity to plus infinity. Let us revise the steps to find the convolution sum using graphical method. First, you need to represent x of n as a function of k to get x of k, and represent h of n as a function of k to get h of k, and fold that signal to get h of minus k. Then you need to shift h of minus k by n units to get h of n minus k. Here n can be positive or negative. If n is positive, you need to shift h of minus k towards right. If n is negative, you need to shift h of minus k shift towards left. Then multiply x of k and h of n minus k to find y of n over the overlapping region of these two signals. Convolution sum can be computed for different types of sequences. It can be two finite sequences, two infinite sequences, and one finite and one infinite sequences. Already we have learned how to find the convolution sum between two finite sequences using graphical method, analytical method, and derivative method in the class. Today I am going to teach you how to find the convolution sum of two infinite sequences. Those two infinite sequences can be two step functions, or one sequence can be a step, the other one can be an exponential, or both the signals can be an exponential also. Let us take an example of two infinite sequences in which x of n is u of n and h of n is also u of n. First, you need to write down the expression for convolution sum and simplify x of n and h of n as u of n and u of n. Now x of k becomes u of k and h of n minus k becomes u of n minus k. Now we need to follow the steps. First, you need to represent u of k. We know that u of k is nothing but 1 for k greater than or equal to 0. To represent u of n minus k, first you need to sketch u of minus k. U of minus k is nothing but the time folded signal of u of k. That is, it is equal to 1 from 0 to minus infinity. Now, to get u of n minus k, we need to shift u of minus k either towards left or right depending on the value of n. Let us take the first case as n less than 0. When n less than 0, we need to shift u of minus k towards left by n units. Once it's done, now we need to multiply u of k with u of n minus k to get the convolution sum y of n. For the simplicity, I have drawn both u of k and u of n minus k on the same graph. Now, if you carefully observe these two signals, u of k exists from 0 to infinity u of n minus k is from n to minus infinity. Now there is no overlapping region where we can multiply the samples of these two signals. Therefore, the convolution sum y of n is 0 for the case n less than 0. Now let us consider the second case, that is for n greater than or equal to 0. We need to shift u of minus k towards right by n times to get u of n minus k for n greater than or equal to 0. Then we need to multiply u of k with u of n minus k. Now if you see this graph u of k and u of n minus k, only the samples between the range 0 to n of both the signals will overlap. So I have highlighted in two different colors. You can see, carefully observe, between 0 to n I have written in two shades. So these are the overlapping regions where the samples of both the signals you can multiply. So now the summation range will change from minus infinity to plus infinity to 0 to n. And we know that u of k and u of n minus k, the amplitudes are 1. So 1 into 1, 1. So which will be simplified to what? N plus 1. So that means the convolution sum y of n is 0 for n less than 0 and n plus 1 for n greater than or equal to 0. So that means the convolution y of n exists from 0 to infinity, and which is equal to n plus 1. When you simplify for different values of n, you will get a ramp signal like this. Now let us take the second example, in which one signal is a step function, the other signal is an exponential function. Let us consider x of n as alpha to the power n u of n, where alpha lies between the range 0 to 1 and h of n is u of n. By simplifying x of n and h of n in the convolution sum expression, we will get y of n as k is equal to minus infinity plus infinity alpha to the power k u of k into u of n minus k. Keep alpha to the power k as it is and just represent u of k and u of n minus k graphically as in the previous case. Now if you observe u of k and u of n minus k, for n less than 0, no samples will be overlapping between the range. So therefore y of n is 0 for n less than 0. Now let us consider the second case, that is for n greater than or equal to 0. In the equation I am keeping alpha to the power k as it is, and we are trying to sketch u of k and u of n minus k for n greater than or equal to 0. Now if you see carefully, u of k and u of n minus k, between the range 0 to n, the samples of both the signals will overlap. That is equal to 1. U of k and u of n minus k is equal to 1 between 0 to n. If we simplify in this equation, summation will change from minus infinity plus infinity as 0 to n alpha to the power k, and this product is 1, which is equal to 1 minus alpha to the power n plus 1 divided by 1 minus alpha. Therefore, the convolution sum between an exponential signal and an unit step function is 0 for n less than 0, and it is 1 minus alpha to the power n plus 1 divided by 1 minus alpha for n greater than or equal to 0. Now let us consider one more example where we'll take both x of n and h of n as two exponential signals, that is x of n is alpha to the power n u of n and h of n is beta to the power n u of n, where both alpha and beta lies in the range 0 to 1. Now simplify x of k as alpha to the power k u of k and h of n minus k as beta to the power n minus k into u of n minus k. Now again we need to find the convolution sum for two cases. One is for n less than 0, the other one is n greater than or equal to 0. Now for the first case n less than 0, y of n is summation k equal to minus infinity plus infinity alpha to the power k beta to the power n minus k u of k into u of n minus k. Let us keep these two factors as it is in the equation and we'll try to represent u of k and u of n minus k graphically as in last two examples. Now we can observe the product u of k and u of n minus k. The samples of both the signals are not overlapping in any of the range between minus infinity to plus infinity. So therefore y of n is 0 for n less than 0. Considering the second case, that is for n greater than or equal to 0, again we are keeping alpha to the power k and beta to the power n minus k as it is in the expression, and we'll try to sketch u of k and u of n minus k for n greater than or equal to 0. If you observe, when we multiply u of k and u of n minus k between the range minus infinity to plus infinity, only between the range 0 to n, both the signals will overlap. By changing this limit in the summation, we will get summation k equal to 0 to n alpha to the power k beta to the power n minus k, and this product u of k and u of n minus k is 1 for the range 0 to n. We will be taking beta to the power n outside the summation and k equal to 0 to n alpha to the power k beta to the power minus k, which is equal to beta to the power n k equal to 0 to n and alpha by beta to the power k. We know that summation k equal to 0 to n a to the power of k is simplified as 1 minus a to the power n plus 1 divided by 1 minus a. Using this simplification in expression 2, we can replace a by alpha by beta. By doing so, we will get y of n equal to beta to the power n into 1 minus alpha by beta n plus 1 divided by 1 minus alpha by beta. When you simplify, you will get y of n equal to beta to the power n plus 1 minus alpha to the power n plus 1 divided by beta minus alpha. So therefore, the convolution sum between two exponential sequences is equal to 0 for n less than 0, and it is beta to the power n plus 1 minus alpha to the power n plus 1 divided by beta minus alpha for n greater than or equal to. Okay, let us revise what all we have studied today. Today we learned how to find the convolution sum between two step functions, one step and one exponential, and two exponential signals. How do we know how many different cases for n this convolution sum exists? Usually for two infinite sequences, there will be two cases. One is for n less than the starting range of the second signal and n greater than or equal to the starting range of the second signal. Let me take an example. We know we have already found the convolution sum of two step functions, that is u of n and u of n. We know u of n exists from 0 to infinity, that is u of n is 1 for n greater than or equal to 0. Even h of n is also u of n, again it exists from 0 to infinity, that is 1 for n greater than or equal to 0. That means to say y of n exists only for what? N greater than or equal to 0. Similarly, for examples 2 and 3, the signals we have taken as a function of u of n only. Therefore, the convolution exists for n greater than or equal to 0. Now, let us take one more example where x of n is u of n, which exists from 0 to infinity, and h of n I have considered as u of n minus 3. That is, u of n shifted towards right by 3 units. That means the sample will exist from 3 to infinity. So, in that case, y of n will exist only from n greater than or equal to 3. If you see the common range between these two, n greater than or equal to 0 and n greater than or equal to 3, what is the intersection? We can see only from 3 to infinity. That means to say for n greater than or equal to 3, y of n exists. Otherwise, it is 0. Dear students, you need to solve the following problems as an assignment. The first problem is x of n is u of n and h of n is u of n minus 3. Both are step functions. And the second problem is x of n is alpha to the power n u of n, that is exponential, and h of n is u of n, it's a step function. And the third example is both are exponential sequences. And the last one is it's a special case of an example 3 where you need to find the convolution sum for the special case, that is for alpha equal to beta. Hope all the concepts are clear to you to compute the convolution sum between two discrete sequences in which both are infinite. If you have any doubts, you can clarify now. Thank you.